Square of. We are going to be going back to the well, as they say, and we're going to be using skills that we learned at the beginning of the year in terms of quadratic equations. Okay, so you need to become familiar with them. What does that mean? It means that by now you should be able to recognize the difference of two squares when you see it. And you should know how to factor that appropriately. You should know that, you should recognize also the sum of two squares and know that that's not really factorable in any appreciable sense. You should know that. So if you had issues with quadratics and factoring, well, you need to go back and review those components in order to be able to be successful in this section. Remember I told you earlier that it was going to come up again, right? Here it is. Yes, also, these types of questions that we're going to be covering in class today are questions that you're more than likely going to see on your SATs. I was tutoring someone a few weeks ago, and a question popped up on their SAT question, and it was actually knowing, it was actually assessing whether you knew this skill. Okay, so let's get enough of the preliminaries. Let's get started. So here's an example of an equation. And as soon as you see this equation here, there are some things that should be popping off, the little red flags that should be going off in your head right now. Right now, this is a quadratic function, right? It has a degree of 4. That means that it should have, at the most, how many solution roots or zeros? 4, right? Also, how many turns should it have? 3. It should have about 3 turns, right? Also, it is an even function, yes? Yeah. So we should pretty much be familiar with the end behavior of this even function by now, right? Yeah. We know that it's probably, and it's also what? It's also positive, right? So both ends are, as f of x approaches positive infinity, right? F of x approaches positive infinity as x approaches positive and negative infinity, right? We should be familiar with the, so we know all of these things from just looking at this polynomial, right? Now, also, we know that if we were to graph this out, right, a table would be ridiculously inefficient in doing this, right? Right? And also, now we should also be aware that we also have placeholders in here as well, right? Yeah. Right? And they're missing, right? So it would be 0x to the third. We have x to the second, and we're missing x to the what? X to the third. To the third. Excuse me, x to the third and x to the first, right? So there's a lot of stuff going on here, right? And so what we're going to discuss today is basically, treating these as quadratics. What do we have to gain by treating these as quadratics? Well, the whole process becomes much more efficient. It becomes easier for us to manage and handle this type of equation if we treat it as a quadratic. Right? Now, will we always be able to treat these types of situations as a quadratic? The answer is no. But there are some warning signs, if you may, that you should always be on the lookout for to let you know if you can treat it, in fact, as a quadratic. Okay? So let's take a look here at what some of those warning signs or hints are. Okay? First, if we compare this to a quadratic, you will notice that there is a 2-to-1 ratio between the leading coefficient, or really the leading coefficient and the middle term, right? And really I'm more referencing the degrees here, right? The degrees here. There is a 2-to-1 ratio. And just to expand on that a little bit more, everybody take a look over here. I'm just going to write your run-of-the-mill, typical quadratic equation here, where I'll have x squared plus 4x plus, let's say it's plus 4, right? That's a typical quadratic equation, yes? And I want you to know something. Remember that our polynomials go in a 2, 1, and none, right? So this exponent right here is what is a 1, right? But if you notice, look at the ratio of my exponents, 2 to 1. There's twice as many as this one as there are of this one, right? 2-to-1 ratio. So when we're talking about a 2-to-1 ratio, we're describing the ratio of the degrees. Does that make sense? Yes? There's a 2-to-1 ratio. So I think we can all agree then, looking at this polynomial here on the board, that there is also a 2-to-1 ratio in their degrees, right?
Yeah.
This one is twice as big as that one. So that's one of the very first red flags that lets us know, hey, listen, I can actually take this function, which is a 4th degree function, and I can actually treat it as a quadratic. Next, hint number 2. If you get confused, your middle term will usually tell you what to do. Okay? Your middle term will usually tell you what to do. And I know that you don't really know what that means. That's what I put up, huh? What does that mean exactly? You're going to see in a second what that means. By the way, guys, you don't have to copy down these notes right now if you don't want to, because I'm just going to post up a picture of them on Edmodo later on. So, is there a 2-to-1 ratio? And if you're not really sure, and if there is a 2-to-1 ratio, but you're still not really sure what to do, you get confused, your middle term will tell you what to do next. Your middle term is going to tell you what to do, and we're going to talk about how you look at that middle term. And using hints 1 and 2, you should be able to turn this equation into a quadratic equation. Okay? Using hints 1 and 2, we should be able to turn it into a quadratic equation. So let me slide this up forward here. Let's proceed. So take a look at take a look at what I did here. So how do I take this and turn it into a quadratic equation, right? Well, first of all, my middle term is what? X
Squared.
X squared, right? So I just took that middle term and put it in the front. And then I need to have a 2-to-1 ratio. So I took it and I
Squared
it, and I left the middle term with a 1 ratio. Does that make sense?
Yeah.
That's why it's very important that we already have embedded in there a 2-to-1 ratio. Because think about it, x squared to the 2nd power, does that give me x to the 4th?
Yeah.
It sure does, right? And then x squared to the 1st power, does that give me x squared with what I started with?
Yeah.
It sure does, right? So all I've done is taken the equation that I had before and I've just rewritten it as a quadratic. And if I wasn't really sure how to do that for the first term, because x squared times to the 2nd power gives me x to the 4th, well really all I gotta do is look where? Look at my
Middle term.
middle term. Does everybody see that?
Yeah.
Everybody understand what we did there? And no?
Yeah.
Yes?
Yeah.
Yes, Tequnique.
No.
I'm sorry, Khadija.
Wait, but what is the middle term telling you?
The middle term is telling me, right, that my first term is going to be the same as it is, just raised to the 2nd power. If you don't, right, because you didn't know how to start this, right? We didn't really know how to begin this. So, look, how do I start this whole process? Well, look at the middle term. Here's my middle term, right? Yeah? Which is what? The middle term is what? X to the what?
2nd.
X to the 2nd, right? So I'm just going to take that middle term, I'm going to move it to the front here, which is x to the 2nd, and then I'm going to raise it to the what? To the 2nd power. That's really the hardest part of this. And then you look at it, well, x to the 2nd power raised to the 2nd, does that give me x to the 4th?
Yeah.
Right? So really, I've just rewritten it, right? I've just rewritten it in a way that now, think about it, look at this. By the way, the middle term stays the same. You don't do anything to it, right? Now look at this. 2, 1, and
No.
are my degrees going in the form of a quadratic?
Yeah.
They sure are, right? Yes, Mr. Barbosa.
Wouldn't it be simpler to just square the whole equation?
Square the whole equation? Well, if you square this and this, then you also got to square that at the end over there, right?
Yeah, but it's a perfect square.
Then I would have to end up with 36 times 36, right? And by the way, it also keep in mind that if I have this times this times this times itself, I would actually have to FOIL those things, right? Does that make sense, right?
Yeah.
If I have a binomial and I square it, it's not easy. It's not enough to say that, oh, I just everything inside gets squared. You have to do the first, outer, the inners, and the last, right? So that would not be correct to do that, would it? Am I right?
Yeah.
Okay. So let's take a look at some more examples. Okay. Notice that all we did was take x squared. Excuse me. Notice that x squared is equivalent to what? X to the fourth, right? And we would stop right there for now. So let's take a look at some more examples.